Hi future adapters, welcome to the next class. In previous class we discussed about electric field and intensity of electric field. So now on that how they are going to ask the problems. We define one definition, electric field intensity E is equal to F by Q naught. According to this, F is equal to Q naught E. So the amount of force acting on the charge placed in electric field is going to be given by this equation. And we have given some properties. What is the direction of electric field? Direction of electric field is always from positive to negative. So this is uniform electric field. So here you have to assume whenever direction is given like this, so obviously here nothing will be seen, but you have to assume always its direction is from positive to negative. This is uniform electric field. So non-uniform electric field, if you are taking one positive charge, point charge, electric field will be like this. It is going to be non-uniform electric field. So it is also going to be non-uniform electric field. So what is uniform electric field means? At one particular point, its magnitude plus direction is going to be same at each and every point. So in this, if it is not same means that is going to be non-uniform. So non-uniform electric field, uniform electric field. So if you are placing one positive charge within this uniform electric field, mainly we will discuss. If you are placing one positive charge within the uniform electric field, so whenever you are placing positive charge, this positive charge repelled by this and attracted by this. Therefore, this positive charge moves in the direction of electric field. So blindly you can remember, always positive charge moves in the direction of electric field. If you place negative charge here, if you place negative charge, so this negative charge repelled by negative, attracted by positive. So negative charge moves, blindly you can remember, negative charge moves in the opposite direction of electric field. So positive charge moves in the direction, negative charge moves in the opposite direction. If you place one neutral charge, on neutral charge there is no electric force because charge is going to be neutral, neither attracted nor repelled, correct? So we'll discuss about this. So mainly you have to remember, positive charge moves always in the direction of electric field, negative charge moves always in the direction of, in the opposite direction of electric field. So if electric field is given right like this, E I cap they will say. So if you place one positive charge here, then what is the direction of this positive charge? In which direction it is going to move means along I cap, positive x axis. If you place negative charge in this, so minus I cap. If electric field intensity is upwards, E j cap, then if you place one positive charge here, so it will also move in the same direction of electric field. If you place negative charge, it will move in the opposite direction of electric field. Next, I am taking electric field like this, E bar along. So whenever they give electric field direction like this, here which charge is available? I said always direction of electric field is from positive to negative. Here you cannot see positive charge. Here you cannot see negative, but always direction of electric field starts at positive, ends at negative. So if you place one positive charge here, now in which direction it is going to move means in the direction of electric field. So whenever it is moving, this Q charge is moving in electric field intensity, how much force acting on the charge? F is going to be QE. If you want in terms of direction, F bar is going to be equal to Q E bar. So this much force is going to be acting on this. So here we will say about magnitude. So magnitude F is equal to QE. Now, what is the acceleration of this charge whenever it is moving, they will ask. Because initially it is at rest position, it is going to be moving in the direction of electric field. So, what is the acceleration, they will ask. So, what is the acceleration means? Simply, you have to go according to Newton's second law, we will write F equal to ma equal to QE, acceleration equal to QE by m. So this is the acceleration formula. Acceleration of the charge in electric field. Now what is its direction? Acceleration direction means this is also towards right side. If you are going to take, it is going to move in the direction of electric field. Now after some time, so after t time, so what is its velocity, they will ask. So we will follow first year equations. V is equal to u plus at. So v is equal. Initially it is starting from rest 0 plus at. So v is equal to at. So v is equal to, what is this acceleration we got means? So QE by m into t. So this is the formula. What is the velocity of the charge after t time? Next, what is its kinetic energy after t time? What is kinetic energy formula? Half m v square. Half m. What is velocity we got? QE by m into t whole square. This is the kinetic energy. They may ask anything. What is the momentum after t time? What is momentum formula? P is equal to mv. What is v? Again QE by m into t. So like this, how much distance it is going to move? How much displacement or distance it is going to move? S is equal to ut plus half at square. So 0 plus half QE by m into t square. So like this, they are going to ask. You have to do once you got idea of this acceleration. So if you drop any object under gravitational influence, then acceleration we will take g. If any charge is moving in electric field, acceleration of that charge is going to be QE by m. Same charge if they give negative, what will happen means it will move in the opposite direction. Again magnitudes will be same only you will get, but direction is going to be opposite. So like this we have to take one by one. Next, if you have taken electric field in upward direction. Now if you place one charge, positive charge in 8, somewhere we have taken positive charge here. So this charge is having some amount of mass. Whenever mass is there, its weight is going to act downwards. Now this positive charge moves in which direction? I said always positive charge moves in the direction of electric field. Therefore on this charge how much force is acting means F equal to QE in upward direction. So how an object is taken on the ground, weight is going to act downwards, normal reaction is going to act upwards. If this object is at rest, N is going to be mg. Same like that, if this charge is at rest, let us assume. If charge is at rest, otherwise to keep the charge at rest position, how much intensity of electric field you should apply, they will ask. How much intensity of electric field means, so here QE should be equal to mg. Why? Because at rest position downward force should be equal to upward force. So if you place positive charge within the electric field, force is acting in upward direction because of this electric field. So because of mass, its weight is going to act downwards. Both are going to be equal. E is equal to mg by q. So this is the electric field, applied electric field to keep positive charge at a rest position. Let us assume after taking this same equation, to keep the charge at rest in gravitational field by applying electric field, how many number of electrons should be present. So number of electrons. Number of electrons should be present within this charge. They are going to ask. At the time, same equation we will take, QE equal to mg. So they are asking how many number of electrons. So we have only this charge. So now what we have to apply? So we discussed already quantization of charge. QE is going to be, did you remember? Ne. So charge is additive, charge is conserved, charge is quantized. There we have discussed this. Q equal to Ne. Therefore, Ne small e into capital E equal to mg. So therefore, small n is equal to what you are going to get? So mg by E. So this is nothing but the number of electrons present within that charge to keep the charge at rest position. So they will give oil drop of radius small r. So density of oil is rho. Oil drop of radius small r. It is having some amount of charge q. Its weight is acting downwards. It is in the electric field which is acting upwards. Therefore, F equal to QE. So what is the radius of the oil drop, they will ask. At the time again same. For this oil drop, mg equal to QE. Charge they have given. So in place of mass, they gave density. So mass can be changed in terms of density. How we will write? Density rho is equal to mass per unit volume. Then mass is equal to density into volume. What is volume formula? Volume of the oil drop, 4/3 pi r cube. So therefore, in place of mass, we will write these things. Rho into. So this equation I am writing in place of mass, rho into 4/3 pi r cube g is equal to QE. So just you can send remaining terms right side. Just I am giving how to take the equation. Mg is going to be equal to QE. In place of mass, you have to write like this. See this, if charge is at rest position, it is going to be how much electric field. If charge is at rest position, how many number of electrons should be present. If charge is having spherical shape or oil drop, they will give all this information for you. So according to that, if they ask radius, means how to change our numbers. So let us assume this charge is moving in upward direction with acceleration a. If this charge is moving in downward direction with acceleration a. So in upward direction, if it is moving, means, so which is higher? Resultant force, whenever we are writing, QE is higher. Therefore, net force, if charge moves upwards, so QE minus mg we will write. If it is moving upwards, at the time what is the acceleration means? According to Newton's second law, F equal to ma. So QE minus mg. Then A is equal to QE by m minus g. With that acceleration, it is moving upwards. If this charge is not at rest position, if it is moving upwards, what is the acceleration means? QE by m minus g. If it is moving downwards, means which is higher? Mg is going to be higher. So at the time, mg minus QE is equal to net force. Net force ma equal to mg minus QE. So then A is equal to g minus QE by m. So like this we are going to take if it is not at rest position, if it is moving upwards and downwards. So these are one model, some models on F equal to QE equation. So remaining we will see in our next class.